So in the last video, we promised that we would look at developing our equations, or showing how we can formulate our equations in our Jupyter Notebook document. And if we look at the code behind this code block, we might imagine that first, before we go and write code centrally the way it's shown there, let's say we wanted code shown in line with the text. So for example, if we want to define, let's say we wanted to define a variable in line with the text. So defining alpha. So let's say we wanted to write defining alpha to be the temperature, right? So we want to stick an alpha in at this position. So we want to say alpha over here, and the way we do that is we use the dollar symbol, and so we use $1 symbol to open the equation and $1 symbol to close it, and then we can type our equation there. So number one, we can just type in text as normal. So let's say we wanted T to be the temperature. And you can see it has this slightly different format, so that emphasizes in this text that this is a variable. So defining T to be the temperature. So this is not just text, this is some symbol. Now we can access all the Greek symbols using the backslash operator, and we can just type the name of the symbol. So for example, if we want alpha there, so now we've got defining alpha to be the temperature. So that's what we do if we want to write equations in line with the text. And we can indeed write equations here. So we can write alpha equals beta squared plus, let's say, zeta. And you can see here alpha equals beta squared plus zeta. And you can see here it's properly superscripted this 2. So when we use this symbol, then that's going to give us whatever follows in the superscript position. And let's say we wanted to add let's say we wanted to make this 2t, right? And that's going to give us an error, because you see it's only going to take the character next to this tilde. So if you want to instruct the compiler to superscript a range of values, then you encase that in the curly braces. So now you can see 2t has been superscripted there. If you want instead for there to be subscripted text, so let's put something else in here. So let's say delta, and let's say we wanted this to be delta 1, so a subscript of 1. Then we use the underscore 1, and we can see now delta subscript 1 in here. And then again, if we wanted more than one character, if you just write that character in, it's not going to put that extra character in the right position, and we have to create a group there by using the curly braces. So that's how we can format equations in that way, and this is still in line with the text. If instead we want to create the equation on its own line and justify it properly and so on, then we can easily do that using, instead of a single dollar symbol, a double dollar symbol, and then that is going to place that down and centered as we see here. So that's the beginning of using MathTex in our Jupyter Notebook document. And if you are familiar with MathTex, then that's probably enough instruction right now. If you want more detail, you can use the Jupyter Notebook that's whose link is in the description. So we can look here in the code. So we'll just look through the code for the remainder of this. So all this stuff, I guess, is pretty standard. Here you can You can create all this from what we've talked about already. Here's one with integration. And let's think about this. All this stuff is pretty easy. We know how to do all that. But we want to create this integration symbol, and we want the subscript and the superscript. Well, that's how we create limits. So in MathTex we impose those limits by using sub and superscripts. But of course we need to create this operator as well. And that's done very easily. Here's the code for that. And you can, I think that's the code. Yeah, that's that code. Actually, it's not. I want the one here for the alpha. So let's look for alpha. So that's the code right there. So this stuff is as we expected it. Here is where we create that integration symbol. And you can see the limits of integration are being created here. So we are saying the lower limit, so sort of the subscript to that integration, is going to be minus, and we want minus infinity there. And in MathTex, infinity is the shorthand for that is INFTY, inft. Right, so that's how we create infinity. So this is minus infinity, and that's going to go into the subscript or the lower limit of this integration. And then right next to it, we would put in that in the superscript, we also use an infinity. In this case, it's going to be a positive infinity. In this case, because it's a slash, that if we use the backslash operator, it's going to look for a sequence of characters that it recognizes. So all of this is regarded as one thing. That's why we don't have curly braces in this case, right? Which perhaps surprised you, right? So when we use that backslash, then the compiler is going to try to identify something to the right of it as the thing we are trying to reference by using that backslash. So it's going to read all of this as one character. Here, of course, we had the minus in front, so it's not really possible to do that here for the subscript. But anyway, if we run that, we can see we get the right rendering, right? It renders as the result that we wanted. And there are several other things we can look at. So if you wanted to represent a discontinuous function, like shown here, we can see g of s. You do that using this begin cases and end cases. And so on. So and there's also this symbol in and not in. So in maths, that's how we read that, right? X is in, it's from 0 to 1, and here X is not in this range from 0 to 1. So there's that. And in fact, one thing that's a little bit missing here is a fraction. So representing a fraction has to be done a little bit more carefully. So let's create a new equation here, and if you go ahead with, let's say, x divided by y, that doesn't render very nicely, right? So if we wanted the form written out in full, then the way to do that is to say, well, this is a fraction, and then it's x and y, and then you just drop that slash there. So when we instruct the compiler that I'm going to create a fraction now, then the compiler knows that it needs to look for two things to create the fraction with. So we don't need the slash there anymore. So when we say frac x y, then it will create the fraction in that way. And of course we can create our derivative symbols like that as well. Right, so that's rendered in pretty much the way that we usually want it to. Right, so with those basics, you can develop quite a large set of equations, and by no means am I trying to be comprehensive in this video. This is just to show you with a few short codes you can easily create your equations, and so you should go ahead and learn as much MathTex as you can. it's quite a large field. There are many variants that you can come up with, and many quick and clever ways you can use to create your equations. And by the way, it will also speed up if you are thinking, well, I just use the math editor in Word or something like that. Well, in Word there is if you hit Alt plus and you start typing your equation, then it's much easier if you know MathTex to use this in Word as well. So Word does have, Microsoft Editor, I should be saying. Microsoft Editor does have some other shortcuts, but by and large, it is based on MathTex as well. So if you know MathTex, really there are many environments where you will be able to very rapidly create your equations. So I strongly recommend you start getting into MathTex and using that with some facility.